going to take Q&A, question and answers.
Yes, Vijay, we have a lot of questions. Some of the questions are already answered.
Yeah.
So there is a question from Mr. Bhushan. No SPD is reusable. I don't know what exactly the question is.
Actually, I understood the question, sir. Generally, SPDs are reusable. They are not like fuse that after each search we have to replace the SPD. Once the SPD fails, you will get the indication through flag or anything, and then only you have to change the SPD. So it is not going to be replaced after each search.
So the question is, SPD is not reusable. Yes, of course. After failure, it's not usable. You have to replace. The next question is, L2 length of the wire is up to earth, soil. I think in the presentation you have shown the length of the wire, L1, L2. The question is whether this L2 is up to earth, soil. So I would like to little bit explain about this question. In a lot of places, due to unawareness, the earth terminal of SPDs are connected to a separate earth pit. This is absolutely wrong. The earth terminal of the SPD must be connected to the common earth bus bar of the panel, and that wire length has to be as short as possible, probably less than let's say 500 or 250 millimeters. So L2 length of the wire, to the answer to your question, L2 length of the wire is up to from the SPD's earth terminal to the earth bus bar of that particular panel or the location. So there is the next question. Please share the difference between positive, negative, and subsequent impulse. Mr. Banerjee, the positive, negative, and subsequent impulse, it all depends on the charge of the cloud, charge and size of the cloud. Finally, what is, sometimes lightning can be of negative. More than 95% of the lightning strikes are of negative polarity. That means the cloud is negative, ground is positive. Approximately less than 5% of the lightnings are of positive polarity, less than 5% of positive polarity. That means the cloud is positive and the ground is negative. So there is a process of explanation of this particular thing, how it is becoming positive, how it is becoming negative, and all this will be too complicated to explain. So in case of a positive lightning impulse, the waveform called as 10 by 350 is applicable. Whereas in case of negative impulse, 10 by 350, the current, the equivalent energy in the form of a current wave shape is 1 bar 200. That means a negative lightning strike it goes from 0 to peak in 1 microsecond and comes to half value in 200 microsecond, whereas a positive lightning strike goes from 0 to peak in 10 microseconds and come to half value in 350 microsecond. Subsequent impulses are the impulse or the discharges which is happening immediately after the main discharge. So there is lightning consists of a main discharge and there can be several subsequent discharges. So what we are talking is positive, negative, and subsequent impulse. So there are several combinations of these. You can refer the standard for more details. So there is a question from Mr. Bhushan. After SPD indicator goes red, we have to replace the particular SPD in the SPD holder. Of course, you have to replace it. So I don't know, Mr. Bhushan is trying to answer something. It is not a question, sorry. So let us go to the next question. There are some questions asked by anonymous members. So generally we don't answer to these questions. Somebody is asking, Mr. Murali Manohar, are you referring to the wire length from the SPD to the load? Yes, of course. The wire length, the one which Mr. Vijay explained is the wire length between the face bar or the line current carrying conductors to the SPD and from the SPD to the earth or neutral. So the parallel wire length was the main discussion, but the wire length from the SPD to the equipment is equally important. So there can be problems of reflections during the surge current or during the operation of the SPD. And if the wire length between the SPD and the equipment is too long, probably in some cases your equipment may not get safety. So you have to, this has to be analyzed by an expert who knows about the SPD and its operation, and then only you should select an appropriate model and install. It's not like you have a panel board, just buy something from the market and install it. Most often it won't work. So not only the wire length between the SPD to the load is also important. Then there is the question, how does SPD differ from surge arrestor functionally? Uh, there is no functional difference. Both are, SPD is a name. These are only nomenclature. Surge arrestor is a name, SPD is a name, TVSS is a name. Earlier somebody asked what is TVSS, transient voltage surge suppressor. All these are names. Due to practice, some people call us surge arrestor, somebody call us SPD, somebody call us TVSS and so on. But nowadays, with respect to the standards, it's all SPD, surge protective device. So functionally, surge arrestor and SPDs are the same. Somebody, Mr. Tiwari, how much technician bend the wire during installation of SPD? Oh, this is a big problem. It's very easy to write in a standard and in a technical book to make it, you make a straight connection. But practically, making a straight connection is most often 99% cases very difficult. As a result, what happens is in the distribution board, we put the SPD in one location and take the wire and connect it to the bus bar. In most cases, this wire length, or let's say more than 50% cases, the wire length is more than 500 mm as recommended. Probably not 50%, maybe even 90% cases, the wire length is more than 500 mm because practically there is a difficulty in installing the SPD. The second subject is SPDs often require a backup protection, HRC fuse. Sometimes MCBs are also used, but the correct one is the HRC fuse. So a wire from the from the phase bus bar to the HRC fuse, from the HRC fuse to the SPD, sometimes the wire length is too long. This is the reason the bus bar mounted SPDs are becoming more important now because it does its function. If you use a normal DIN rail mounted SPD and connect it with a long wire, probably the SPD is SPD will exist there, but it won't do its intended purpose. So to the question, how much technician bend the wire? Okay, it depends on the technician who is doing it. We have to train the technician in such a way that they are not making any bend in these connecting wires. It should be as straight as possible. Mr. Suhas Shah, how can we connect bus bar type SPD for DC application? Yes, Mr. Suhas, for large solar PV inverters on the DC side, these bus bar mounted SPDs are used. The method of connection is same between the bus bars. The panel board designer should design this particular thing in such a way that these SPDs, there is space available to mount these SPDs. Someone is asking image of bus bar mounted SPD connection. Probably Vijay, you can share the screen and you can show how the bus bar mounted SPDs are connected. Vijay, I will continue reading the answer. Probably you share the screen and you show how the busbar mounted SPDs are connected so that it is easy. Yeah, you can make it full screen.
Yeah.
So in this particular case, the picture which is on the left side top, you can see the length of the wire. There is a wire used, but the length of the wire is too short, maybe about 200 millimeters. From the bus bar, it is directly connected to the terminal, and the earth terminal is directly on the bus bar. The figure number 2, left side bottom. Here, the bus bar, you can very well see the SPD is connected in between the bus bars. So in the case number 3, which is the center picture, of course, a wire length is used. Of course, a wire length is used, but we have to ensure that this wire is very short. So these are some of the typical ways of installing. Someone asked, Vijay, you can show the screen 2000 number of strikes. Someone is asking, what is the time gap between 2000 surge shots? Not this one. The previous. Yeah, this one. Please note that on the table classification, class 1 10 by 350, class 2 8 by 20, multiple current impulse 8 by 20. So your question is about this multiple current impulse. Strikes orb 30. This model 2000 into 10 kiloampere. So 10 kiloampere strike, 2000 numbers. Probably this 2000 numbers, once when there is a discharge, the capacitor has to be charged again to make the next stroke. So after each discharge, it needs some time. Probably if someone is working for 8 hours shift per day, he may be able to make maybe 50 strikes. So into number of days, you can calculate. These are made in this fashion. Now, another subject which is of important is normally an SPD, a DIN rail mounted SPD, is tested with a surge current. Then immediately the SPD becomes hot. The next surge has to be, or the next test has to be carried out after cooling down the surge arrestor to its normal temperature. In practice, lightning will not wait until the surge arrestor is cooled down. Lightning probably sometime it's a continuous process. It may strike within few seconds. Several shots may happen within a short time. Now these SPDs, strikes of 30, 40, 80, the number of strikes which it is made 2000 into 10 kiloampere, this is over a period of time. But multiple strikes, one after the other, each of these SPDs are also tested for 7 to 8 times continuous. That means immediately after, one after the other. So this is actually a very big advantage of these SPDs. You must have seen on the earlier picture, it is made with an aluminum housing. So aluminum act like a heat sink for the MOV. So as soon as the MOV is hot, it is cooled down quite faster in comparison to a DIN rail SPD, and that is the reason these SPDs are able to withstand the multiple strikes. You can see the last one, strikes of 80, 100 times 65 kA, 2000 times 10 kA, and after that, multiple high energy handling. See, the lightning also consists of a long duration stroke. So there are positive strike, negative strike, subsequent strike, and a long duration stroke. Long duration stroke is a small current but flowing for a longer duration. These SPDs are also tested for that particular purpose. You can see on the strikes orb 30, 250 shots, 250 amps, 2 milliseconds. 250 times these SPDs are tested. Each of the current flow is 250 amps, and that means the surge current is 250 amps, and the current flow, the time or the duration of the current flow is 2 milliseconds. So in comparison to a microsecond phenomena, the long duration stroke is for few milliseconds. So the last test, multiple energy handling, this is for a long duration. Long duration in the sense, in comparison to an 8 by 20 microsecond stroke, 2 millisecond is, you see, almost 100 times or more duration. So, to the answer to your question, time gap between 2000 numbers is short. If you look at between each and every shot, probably 2-3 minutes at least, or even more. But continuously, it is also tested for 5 to 7 strokes without failure. The SPD didn't fail. Next question, where to put SPD in any hospital? At the main panel or elsewhere? You see, we cannot answer immediately in this case. We have to find out, find out how the whole electrical installation is designed, and then what kind of protective measures you already have and what kind of protection is required for your equipment. So the correct answer to your question is where to put SPD in any hospital. SPD is a critical component as far as the SPD manufacturer is concerned, or as far as the electronics engineer is concerned, because he has to protect some electronic equipment. But once when it comes to the electrical installation, the whole electrical installation, starting from the transformer up to the wire, switch gears, several type of protective devices, meters, automation, and so on. So if you compare the importance of SPD in the whole electrical installation, it is one among probably thousands of devices which is used. So it is not like you buy some SPD and connect it in your network. Most often it is dangerous. So you have to analyze your electrical installation. You have to find out what kind of electrical installation is there. For example, what kind of system earthing you are doing. Is it a TNS system, TT system? Which location you are trying to make, whether it is at the mains incoming panel or inside your panel, then your protection, you are achieving common mode or differential mode. There are so many questions. So based on that only we can select. It is not like one model of SPD you can use everywhere. It won't work if you need a proper surge protection. Then Mr. Bernard Lawrence, for a 4000 ampere bus bar, SPDs are available. Of course, for 4000 amps bus bar, SPDs are available, but these SPDs which is shown, these are only tested for up to 1600 amps circuit breaker or up to 80 kiloampere fault current. So the question is 4000 amps bus bar SPDs. This is actually, this is a different kind of discussion, because normally at the mains incoming, a 10 by 350 microseconds SPD is recommended, and we always put a very big surge arrestor or a surge arrestor with a very high discharge current or impulse current capability in the mains incoming panel, such as a 4000 amps panel board. But in practical, 4000 amps panel board, this 4000 is connected to the terminal of a transformer, which is either inside the building or very, very close to the building, maybe 10 meters, 20 meters away from the building. 10 by 350 microseconds SPD is selected based on a principle 50% or based on the assumption 50% lightning current goes to earth and 50% lightning current is diverted to the mains incoming. But the point is, this 50% current, lightning current diversion to the mains incoming is possible only if you have a long connecting wire, low voltage electricity connected to a consumer premise from a transformer, let's say 1 kilometer away. In that case, large current will flow. Whereas if your transformer is very close to your electrical main switchboard, or if it is within the building, 10 by 350 current you cannot expect, or you don't need such a large an SPD with a large current flow. But for a 4000 amps application, you have to be very careful in selecting the SPD, because It's very critical. We have another model of SPD. Probably in the next presentation, we will show that an SPD with inbuilt backup fuse. So those SPDs are required for that application. I'm sorry that so many anonymous questions are there. Anonymous attendee, we won't be able to answer those questions. What is the purpose of having a breaker before SPD? What if we don't have it? Also, how to select the rating of the breaker? This question is by Mr. Arun. Mr. Arun, these will be addressed in the next program. We are having the part 2 of this webinar. So there we will explain about the selection and erection of backup protection, whether it is a circuit breaker or whether it is a HRC fuse, and the basis of those selections. So, Mr. Subrata Sahu, when we install SPD in a transformer on HT panel, the wire length from SPD to earth station or earth bus is generally more as per site condition. Has it effect on the performance of SPD? Is the equipment duly protected? Whether it is, the answer is whether it is LT or HT, irrespective of the operating voltage. If the connecting wire length, the technical word is lead length. If the lead length is higher, the equipment is not protected. Higher voltage goes into your system. The performance of the SPD is reduced in this particular case. So, the next question. Is there a correlation between effectiveness of the surge protection device and degradation of earth impedance value of its P connection? Is there correlation between the effectiveness of the surge protection device and degradation of the earthing impedance value of its P connection? Mr. Ilaling, actually the question I am unable to understand. Probably once when few of the questions are over, we can have a chat and explain this. If anybody wanted to discuss, or if anyone wanted to have a question, you can raise your hand. So we will allow you to get unmuted so that you can also talk. Mr. Bhushan, you are raising your hand. If you can talk if you wanted to talk. Mr. Bhushan, you have to introduce yourself and then please speak.
Yeah. Good morning, all. This is Bhushan Mankame, electrical engineer from Electrical Inspector's Office, Mumbai. And I'm based in Mumbai. We are working for the state government department. Sir, one question I had is in the LT network of licensees, there are a lot of switching surges. And these switching surges cause problem in the electronic circuitry, the PCBs, and burning of cards. This is a common phenomena in printing industry and even in hospitals where critical biomedical equipments are present. So my question is, which type of SPD is suitable for protection from switching surges in the LT network? That's all from me. Thank you.
Thank you, Mr. Bhushan. The answer is it's a type 2 SPD. So the SPDs are classified into type 1, which is type 1 is for, it's a bigger SPD which can handle a lightning impulse current. The second one is a type 2 SPD, which is a smaller SPD which can handle switching surges. So it's a type 2 SPD you are supposed to use for this particular purpose. But please note that SPDs are only for the transient phenomena, means for the phenomena is for a short time. Most of the time, if we discuss about the public distribution, more than transient phenomena, there is a temporary over voltage. Temporary over voltage is for a longer duration. It can be up to 5 seconds. not like a few microseconds, it can be up to 5 seconds. These temporary over voltages are due to fault on the HT system, extra high voltage, the HT system. Let's say, for example, on the 11 kV system, there is a fault, and during that time, LT supply or this LT supply from the transformer can experience a temporary over voltage, which will exist for a longer duration. And a lot of cases, devices are failing due to this temporary over voltage. So here, even if you put an SPD, it won't provide the necessary protection. The energy supplier shall take care of it, and they have to make necessary arrangement to limit the transient or limit this temporary over voltage. So this is sometime we have to be a little bit careful. Thank you for the question. We have
Sir,
the
sir, can I add the subsequent question with your kind permission?
yes, please.
Yeah. So the point that you said is we have to use type 1 and type 2 SPD for the protection of these electronic circuitry. So now this next question comes in my mind is, what is the range of protection in type 2 SPD one should select?
Yeah. If you can go to the range, in the sense you are talking about the current range, because the devices have parameters related to current, impulse current or discharge current, and voltage. If the question is with respect to current, you can go to the National Building Code, Part 1, section, sorry, not National Building Code, National Electrical Code, which was published 2 months back. Part 1, Section 13. So there the different conditions and different ratings are also written. NEC, Part 1, Section 13. Please refer that. Thank you. Because, depending upon the
Thank
condition,
you, sir.
the rating.
Thank you very much.
Yeah. Thank you, Mr. Bhushan. Then Mr. Murali Krishna, how is safety
So
auditor have
we
to evaluate SPD online? Yes, Shonali?
so we have Mr. J who is waiting to ask a question.
Yes, Mr. Jay.
Sir, good afternoon. Jay here from Medicare Industries. Am I audible?
Please go ahead.
Am I audible, sir?
Yes.
Acha, regarding one question which has been asked by the person from the Inspectorate Mumbai office, Mr. Mankame, regarding if there is any device which can be used in hospital due to the transient effect of switching. Actually, I have come across one stabilizer kind of thing. What they call is that static voltage stabilizer. Okay. So if this is being used, it can help in hospital to overcome uh, over voltage, which is lasting for more than 5 seconds or 5 seconds, what we are discussing.
It is also not 100% true. Depends on the amount of the voltage which is going to come and its duration.
Correct.
This temporary over voltage, actually the consumer have little control over it. It has to be limited by the energy supplier. If the transformer belongs to the consumer, of course, yes. For larger hospitals where you have your own transformer, of course, you can control it. Whereas if it's a public distribution, it's very difficult to do that. There are several solutions available, but none of these solutions are effective. The best way is the energy supplier or the transformer owner should ensure that such voltages are limited to less than certain level. Thank you. I hope my answer is clear, Mr. J.
Yes, yes. But to add to this one supplementary question, I have posted in Q&A also. Like I belong to basically electronics background. So in general, for such incidents where over voltage is there for more than 5 seconds or 5 seconds, the term VDR, that is voltage dependent resistance, is connected between phase and neutral for a single phase device. And at times I have seen in some 3-phase inverters also that they are connecting this VDRs, voltage dependent resistance, or what you rightly said, that TVS, transient voltage suppressor devices. These are connected directly between phase and neutral rather than what we are discussing today, SPDs, which are connected between phase and earth, neutral and earth. So like point what I'm trying to say, that if you want protection for longer period for a particular device which is operating on a single phase, we can use a VDR, which is nothing but a SPD only, but it should be connected between phase and neutral, and it should be after the MCCB. So if the
No, you see, there are several practices in the industry. Now, the device which is the heart of the device inside an SPD and the device which you are talking, it's all maybe MOV, or MOV, metal oxide varistor, which is nothing but voltage dependent resistor. Once when the voltage goes beyond a certain level, the impedance in between the terminals goes to a very low level. So it's all voltage dependent resistors only. But the problem is, the significance of SPD is, or the problem of this voltage dependent resistor is, it always fails in short circuit mode. So inside your, let's say a drive or something like that, immediately after the circuit breaker, between the terminals, if you are using an MOV, generally what happens is, after some time, this MOV is a source of fire, because the MOV fails, it creates short circuit and it catch fire. SPD is also, the heart of SPD is also type 2 SPD, most of the time is also an MOV. But once when it is made as an SPD, necessary safety measures are included in the SPD, such as once when the temperature is beyond 80 degrees centigrade, then the MOV is disconnected from the line. Number 2, once when the short circuit current is more than certain level, the MOV is disconnected from the circuit. So SPD is a device which is a safe device in comparison to a device directly connected between the line and the neutral. So basically, the heart of both the devices are same. I hope it's clear.
Yes, sir.
Thank you.
Thank you, sir.